In question 5, we need to integrate the function y equals the square root of 9 minus x. Now this curve intersects the coordinate axes at 0, 3 and 9, 0. And you can see that by simple substitution for y equals 0 and x equals 0 respectively. Let's use the graphical calculator to plot this graph. It's option 5 for the graph function menu, and it's the square root, that's shift x squared to get the square root, of 9 take away x. And then I use the right cursor to move away, and if I select execute and F6 to draw, I start to get part of the function. I may wish to change the scale, so if I go to V window, I'm not going to keep the maximum as 6 point something because I already know that I want to integrate it between 0 and 9. And so let me change this to 15, something larger. I may need to try and change the maximum for y as well, but for now I'll keep it as 5. If I select execute and F6 to draw, okay, so that seems to be fairly reasonable. So now if I integrate this function, that's gsolve, and I scroll using F6 to the integral function F3, and I wish to integrate this function with respect to x. It asks me for the lower limit value, and of course that's 0. And if I select execute, it now asks me for the upper limit value, which is 9. And after integrating, I get an integral with respect to x of 18, which agrees with my calculation. Remember, this function is not defined for x greater than 9, because 9 take away a number bigger than 9 would give you something negative, and within the real numbers you cannot find the square root of a negative number. If you did want to check the points where the curve intersects the coordinate axes, we can do this using gsolve as well. The y-intercept is at f4, and you can see here it's 0, 3. And again using gsolve, if I wanted to look for the roots, f1, the root is at 9, 0, which again corresponds to that point there. So the graphical calculator has been useful in this question.